we can start. Hi everyone, I'm Anvesha. I work at Hasgeek. Welcome to today's session. I'll start by introducing the hackathon. So, as most of you may know, we have an open source AI start. Hi everyone. Yeah. So the aim of this hackathon is basically to encourage individuals and teams to apply AI ideas and use cases to open source projects. So anyone ranging from a student to a working professional, consultant, researcher, anyone can apply and participate. The criteria are that the ideas should be open source, the code should be open source, and your code should be orchestrated in a way that it can work with open source products, platforms, systems, and tools. Um, so how you can participate is you can submit your project idea on the submissions page. I will share the link on Zoom chat, and it will also be shared as part of the updates on the project page. You can join the Fifth Elephant WhatsApp group and the Telegram groups to sort of discuss your submission with the mentors over there. Um, and then once you've submitted, you can start working on your ideas. And the demo day will be organized on Feb 2nd and 3rd, and when you can demonstrate your projects. And then the winners of the five tracks that we have, each of those winners will get a prize of rupees 1 lakh. So we have five mentors as of now. Bharat Shetty, who is an AI ML consultant, he's worked for Airtel and other organizations on AI ML and across various verticals such as AI, EdTech, IoT, and healthcare. He's also the editor of the Fifth L Winter Edition and also the papers discussion community. Abhishek Mishra, who's the speaker today, is a PSF fellow and a software engineering enthusiast. And he's also driven tech in events such as PyCon India, APAC, Chaos Carnival Conference, and others. We have Aniket Maurya, who's spearheading the creation of intelligent software using AI and is a developer advocate at Lightning AI. He's also the creator of Gradsflow. We also have Simrat Hanspal, who has a career of over a decade in the AI ML space and specializes in NLP. She's currently spearheading AI product strategy at Hasura. Lastly, we also have Sumod Mohan, who's the CEO at Auto Info, and he's worked for over a decade in computer vision, NLP, and robotics. Um, you can also, as part of the hackathon, you can have up to three members in your team. You can also submit projects individually. And the tracks are, scientific research, inclusivity and accessibility, creative expression, education, and AI for India. So that's about the hackathon. If you have any questions, you can reach out to us in the WhatsApp Telegram groups. You could also drop a comment on the hackathon page. And now to introduce today's talk. The talk is on how good data sets can shape state-of-the-art AI models by one of our mentors and the creator of Code Cherry Pop, Abhishek Mishra. Over to you, Abhishek. Also, lastly, if anyone has questions, please drop them in the Zoom chat, YouTube chat, or under comments on the Hasgeek website. Thank you.
Yeah, thank you, Anvesha. So, good evening, everyone. Thank you for being here today. My name is Abhishek Mishra, also known in the digital realm as Token Bender. That's the pseudonym I use whenever I'm doing any experiments or putting out any models or datasets. I'm here to unravel what many consider the alchemy of artificial intelligence. Alchemy sounds like a big name, but it truly is a conundrum when people are asked the question, what good data set actually looks like. Because everybody says that a model's pivotal point is its data set, but exactly what do we mean when we say good data set? So today we will explore the critical elements that are involved in data curation, as well as like uh, all the inputs that actually go in, all the thought process that go into curating and building really good sets. So let me jump into it. Before I start, I would like to put these two quotes out in front of you. Both of these are slightly counterintuitive to each other, but it is necessary to have both in front of you, because when we say that a good model is actually proof of having a good dataset and not exactly a better architecture, this statement is true. However, when we talk about state of the art weights, or when we talk about state of the art models that actually people release and put them out in benchmarks in each place, essentially those weights or those models are just the best model checkpoint. And I wanted to press with this because I really wanted to highlight that it is true that a good model is completely reliant on a good dataset. However, just a dataset itself isn't something which is all that it takes to build the best performance checkpoint for your particular model. So let's go to the next slide where we cover the intuition and nuance involved in it. It's not that complicated to wrap your head around the idea of like exactly how a good dataset might be almost entirely responsible for a good model. Why? Why is this intuitive to a lot of folks? Because everybody is aware of the idea of gigo to some extent. Gigo is like garbage in, garbage out. So if the uh, if the data set that you're actually training or finding your model on is equivalent to garbage, then the result is also going to be equivalent to garbage. However, uh, just this intuition or just this insight isn't something which is good enough, because as I previously mentioned, lots of other things also get involved in building the best state of the art models. The entire focus of this talk would be on dataset. However, I'll just mention these things once so that we don't miss the nuance uh, uh, that these other things and exactly the work that goes behind coming up with the best checkpoints uh, isn't neglected. So good dataset is all that it takes to build a model, yet tuning hyperparameters, running your evals, and building the right evals are what give us the optimum checkpoint. I have shared a I've shared a screen. So I actually shared a snippet of a chart, which is from one state of the art model that I made, and there you can see eval with respect to bench average accuracy. So as you can see that with each and every checkpoint, the performance of the model checkpoint was varying a lot. So dependent on exactly how many epochs it took, or exactly which particular checkpoint you ended up with, the benchmark scores would have differed slightly. Okay, so eval performance in such scenarios varies across checkpoints. This is something which needs to be understood, and that is why often when we are building state of models, we run these for really long epochs because we really don't know exactly when the best checkpoint is going to arrive. A difference of few percentage is easily observed in finding the most optimal checkpoint. So now that we have covered that nuance, I would like to start focusing more on exactly uh, the main crux of this topic. And before that, a little bit of background on me. Previously, I have worked as a technical lead, uh, AI in firmware, Intel Technologies Private Limited, and currently I am primarily focused on just hacking away at the edge of state-of-the-art LLMs. I try to learn, share, and ideate on everything related to local model system. In the past few months, I conducted lots of experiments and got to learn lots of things. Uh, I was I was able. So when Llama first launched, I was I, when Llama 2 first launched, I actually built a series called Code Cherry Pop series, which was the first useful coding or assistant model. It was a 7 billion parameter model. Afterwards, afterwards I continued experimenting with some Indic language datasets as well. I picked up popular SFT datasets in English or in Chinese and tried to translate them synthetically using Meta's seamless M40. I created an equivalent Hindi fine-tuning dataset, and with that I also created Llama 2, which was a 13 billion parameter Hindi fine-tuned model. I wanted to build the best of the best models, not just do some stuff which was involved at learning how to fine tune things or learning how exactly how the tool set goes. So In that, I pushed and was able to and was successful in building the best 1 billion parameter OSS coding model. This involved me to do both uh, SFT as well as DPO fine tuning. And the final score for the 1 billion parameter model was on human eval, it was 68.29%, and on human eval plus, it was 67%. The model is known with the name evolve sequence, and all the details as well as like the evaluation is transparent and present on Hugging Face itself. I also experimented with building generic SoTA models because I really didn't want to focus on something very narrow. So I continued doing stuff and I built a generic SoTA model which I named PIC. PIC stands for partner in crime. It's something which is supposed to be good at multiple things like like being an assistant, function calling, coding roles, and right now it's actually one of Hugging Face OpenLLM top 7B Mistral fine tunes. It has been fine tuned from scratch from the Mistral version 01 release that was there, and all the dataset all the dataset details that have been used to actually arrive at the final pick model have been open sourced as well. And so far I covered code generation models as well as your generic SOTA models. But I was also been active in working with role play models uh, because there is a very famous character AI company called Chai AI. They have monthly competitions, and for the last 3 months, I've been working with them, and I've been submitting my models in their competitions. So I have consecutively participated and have placed in top 10 multiple times as well as top 5 with 78% plus upward ratio. With all these, I was able to learn lots of things about building good code generation models, good generic models, and building really good role play models as well. In the entire journey, one thing that I understood was exactly how important data sets are. And when we really want to get something, whether it is hitting a benchmark or whether it is satisfying human preference in certain areas, exactly what needs to be done. Uh, Right now, I run experiments Discord server where I discuss, share, and conduct my experiments and ideas. And now let me try to share all the learnings and all the ideas that I gained in all these experiments, and hope you guys gain some good stuff out of it. Okay. So when I say that we want to talk about good data sets, uh, it's a very difficult question to answer, as I mentioned previously. I'll say there is an easier question to answer. The easier question to answer is, what is a bad data set? How would I define something as a bad data set? So I'll say that a bad data set is something which hypothetically is something that is guaranteed to harm your model. Okay. So when I say bad, it exactly means like the data that actively harms the model's performance. For example, if I was to give you a hypothetical scenario where I was to add this particular mix of data to your data set, it is sort of guaranteed to harm your model in some capacity. Okay, that's what I mean when I say what's bad data to give to a model. And the second point is, what's the best way to teach an emergent system? Why do I say emergent system? Because the behavior characteristics that these LLMs have showcased so far, uh, the way they respond to humans, the way we prompt them, the way they get slightly lazier in December, the way they respond to $200 tips or other sort of thing. There's a lot of anthropomorphization that has actually happened with these models, and it has been successful in lots of ways as well. That's why when we work with these systems, we have to experiment a lot, actually treat them, actually anthropomorphize them, even in building your data sets, and continuously think about that. If it was actually a toddler, how would you teach it? Or if it was actually a person, how would you teach it? That kind of thinking isn't unrewarded in this domain, and is actually like there are lots of research and lots of papers that have actually been published just on these ideas only, and we'll be covering some of them here. So these are the 2 points that we will have to cover. when we talk about defining good data set. The first will be exactly what it means to say something is a bad data. So once we want to answer exactly what does it mean when we say something is a bad data, let's go towards the first point. Um, the first point is removing truncated items. This is the first point that I have on this topic. And when I say removing truncated item, it means that we are discussing web extracted data, because we are talking about pre-training data sets. We are talking about lots of data sets where people have scraped data from several websites, books, or some other places. And in these places, because of the nature of the tools with which we interact with them, because of the API calls and some other tools which continuously go for a uh, retrying scraping, and they have to resume from their last place, and they also observe lots of failures and uh, blockages. So because of these, because of these scenarios, truncated data being present in your pre-training chunks is something which is seen very often. If you have done the same thing on your end, and if you have and if you have collected your own data by scraping something, or by or scraping a website or a book or something, then you should expect something similar on your end. Even when you're like synthetically translating the data set from one language to another, you should expect some sort of error rate, some sort of failure in translation of individual sentences or documents. And in those scenarios, you would also observe lots of repeated or truncated data. So this is something which we have identified and understood, that if truncated data is present in your data set, then that is something which is an incomplete, unreliable data, and it has a very high probability of harming your model performance. So when we say something as a bad data, which is guaranteed to harm your model, it's any sort of data which, in a sense, is something incomplete or unreliable. However, since we want to programmatically extract these things, we identify this right now as removing truncated items. Lots of uh, lots of time, it is very hard to programmatically correctly identify whether some sentence is incorrectly truncated or not, or incorrectly terminated or not. We aren't living in pre-LLM era. We actually have really small useful models like Tiny Llama, Stable, Zephyr, and Phi, and we can either fine tune these models or just go with their regular inference. Like, we can give them a simple data chunk as in the instruction, and we can ask whether the model can identify truncations. We can even force it to answer just simply true or false, or go descriptive, whichever is our preference. I've shared a snippet of the same, which is from Stable LM Zephyr. Here you can see that the instruction is something of a text chunk, and the text chunk, it has shared a chunk which is incomplete. And the model has responded that the text seems to be incomplete as it does not conclude the key elements of the process of photosynthesis in plants. It also has a mid-sentence cut with this is crucial for production of appearing to be incomplete part. So as you can see, that Stable LM Zephyr was correctly able to identify, and not only able to identify, it was even able to list out exactly what were the things which were missing. So here is somewhere where comes the utility very small models which like nobody's using. But when it comes to working with data sets, one can very easily use a 3 billion parameter quantized model, which can be hosted in like 1.5 gigabits of RAM, and you can run your entire data set through it, uh, even on a MacBook, or something which requires something which just has a simple CPU, rather than being completely dependent on GPU. And you should be able to leverage it to perform such analysis on your data chunks as well. Now, the second point is cleaning ill-formatted noisy text. When I say cleaning ill-formatted noisy text, I'm actually talking about purifying the data set by removing any sections or rows that are not formatted correctly. When we say exactly what it means to be ill-formatted, we are talking about being cluttered non-essential examples. We can take an example of an email. let's suppose I've scraped an email from somewhere, and almost 75 to 80% of the page is full of just formatting or some headers or some other web information which isn't which isn't covering the core message. Likewise, you would have some scrapings from GitHub, or you would have some other documents from different places where there might be lots of formatting involved because of the tools which were part of the process, because like each and every endpoint is adding something to their payload and wrapping it in something, or presenting it in a format. So with all these with all these challenges, what ends up happening is that some section of your data can potentially be ill formatted. Identifying it and removing it is something which improves the quality a lot. Now let's talk about the third point. And the third point is fixing samples not adding to instruction format. Okay. Uh, this is something which, like, your data can be complete. It is not truncated. It is very well formatted. The way you expect the instruction and response to be human readable, it is there, perfectly is there. And these are the things which you won't catch with a simple programmatic tool. You will to catch these with some sort of linter or some sort of regex check. But it's something which is just absent from the response. The instruction has mentioned that it has to list out the answer in alphabetical manner, whereas the response uh, follows a process, lists out the answer, but it is not an alphabetical manner. These are the things. This is just an example, but like there are several such examples, and these are the scenarios where typically you have a challenge of of having things that are hardest to identify without human perusal. Okay, again, in these places I recommend using very small models like Tiny Llama, Phi, Stable LLMs, just experimenting out with the right one. If your needs are defined exactly what you're looking for, what kind of instruction response pairing you're looking for, you can even create a small synthetic data set and fine tune the small model to perform this check for you. It will go through the instruction response pairs of several 100,000 rows of your dataset, and it should be able to completely take away the need for relying on humans or any sort of human perusal, and it will be to eliminate all those bad portions of your dataset, thus improving the quality of thus improving the final model performance. And the final point is the least glamorous one. It's also the most simplest one. This is something which has been present in pre LLM days as well, and it's most that is essentially your deduplication. But say deduplication, normally how people go about it is they would just look for either document level deduplication, or they would look for uh, each and every row deduplication. For example, if you have 100,000 rows, then you would run some sort of deduplication or some sort of hash check on on each and every row. However, line level deduplication is also something which is necessary, because as I mentioned previously, often the data sets that we create are used with the help of are something which we create with the help of scraping or synthetic translations or other mechanisms, and in these cases one may receive a single response multiple times as well. So it's possible that you have eliminated all your document level deduplications, like your documents are unique, but in the document itself there may be hidden portions where the same line or the same chunk has been repeated multiple times. The same thing can happen on character level as well. So when somebody is deduplicating, they want to they want to cover document level deduplication as well as line level deduplication. And if their tool usage is such for creating data set, if their tool usage is such that they can expect some sort of character level repetition as well, then they should look for character level deduplication as well. If we cover all these things, this was the easier question to answer. If we cover all things, then we will say that we actually have removed almost all the scenarios that may be responsible for reducing the model performance. Next, we will venture into the territory, which is something most people are experimenting on, continuously figuring things out. Every 15 days or a month, we see some new method that identifies how exactly can we get the model to perform better, whether that is self-reflection, whether that is using step-by-step thinking approaches, or it is something which just simply asks the model to pause and generate information, or just ask it to use some sort of think token, explain what it is doing, and then generate its answer. As we mentioned, as we discussed previously, these approaches are something which completely have taken hold, because now we have started anthropomorphizing these models. We are teaching these models intelligent to some extent already. Even though I wouldn't go and discuss anything about whether these models are AGI, or whether the current architecture would actually reach AGI or not. But it is true that being trained on human data, uh, almost entirety of human data that is present on web, a lot of things that these models have picked up, like being bribed, like being threatened by somebody's life, like being what should I say, actually being exposed to something like December being a lazier month for them to actually put stuff in. Something as weird as this also exists, and because of this particular area where we are trying to understand how to teach something which might be an emergent system, becomes very interesting. And there are lots of approaches. All these approaches have some portions of these been developed already. Some portions are still being researched, but this is that one area where we actually expect to see a lot of information to be continued in 2024. We actually expect lots of new research papers where people anthropomorphize more in terms of generating data sets, or just working with your specific set of system instructions that bring out more flavor from these models. So these are the areas where I expect lots of things to happen. However, let's discuss exactly what do we know concretely so far, or what we have learned through all the experimentation that we have done in the past few months. I would say that I have tried to understand and abstract the idea of good data set, or exactly all the data set techniques you would need to teach an emergent system, in 5 points. The first is diversity. The idea of diversity is intuitive, in the sense that if we have to teach a model something, just teaching it a bunch of examples isn't going to be good enough, because then it will lean more towards memorization. So let's say if I wanted a model to actually be capable of answering questions for an entire area belonging to a particular topic, I would want to cover it in as much diversity as possible. So when we say diversity, again, uh, the challenge that lies in this particular area is how people quantify diversity. Previously, we covered deduplication. Measuring deduplication, and then performing is easy, because like you can always say that I want to identify 95% similar data, and then delete that, and then drop all the documents, or drop all the rows or lines that are 95% similar, right? But when it comes to diversity, we have both the challenge of exactly first defining how many topics we will be covering, and when we say we are covering all these topics, exactly how many examples we would need per topic, and then also somehow hope that that is good enough. So the methods that people come up with right now is mostly rule of thumbs, based on the total of the data set. If we want to have, if let's say 100% is the total size of the data set, I want to have 300 clusters or something, and each of these clusters, and 300 clusters, like the major chunks should be represented by 1% something of this sort, and all the smaller portions could be your 0.25% or 0.15% of this sort. So these are the ways right now we are diversifying data in state of the art. Anybody who is building a huge data set like OpenHermes or any or John Durbin's Ouroboros dataset. So all of these people would have some some topics where almost like 1%, 2% of the entire of the entire dataset would be focused on, whereas there will be other smaller chunks as well. However, we don't want any chunk to be very small. So we want it to be diversified enough. We want all of the chunks to be bigger than a particular number. So exactly coming up with some sort of heuristic, like a perfect heuristic, is something which is really something which is something to be discovered in this area. Right now, people are using thumb rules and heuristics to identify diversity. We just have the idea of diversity, but coming up with something like an exact number, you can expect that to be in some sort of research paper coming in next few months or something. So let me jump to the next topic, which is perplexity. Essentially, when we talk about perplexity, let me first define it exactly in the context of LLMs. Perplexity is something which is your exponential loss for a particular chunk of data, right? If I was to define it in very simple terms, I would say that the lower the perplexity of a given piece of text, the easier it is for the model to generate the same piece of text. Okay, so so lower perplexity means higher chance of generating that. Higher perplexity means lower chance of generating that. The most standard approaches in, in all the dataset filtration techniques that we have right now, it is to assess the perplexity of all documents and rows and reject all below a certain threshold. So, for example, there is a very famous LLM called DeepSeek, and in DeepSeek, what they do is they calculate perplexity of all the documents and they drop everything below for 50% perplexity. What does it allow them? It allows them to only focus on the chunks of documents that may contain information that model will benefit from learning. Whereas all the chunks that it has that it can easily generate itself, it it may not really it may not really need to learn. Again, dropping and deleting these documents as well as rows isn't something very straightforward, because you have to balance out other factors as well. For example, diversity itself. You wouldn't want to delete these rows or documents completely arbitrarily so that your diversity gets compromised. So there is some sort of balance has to be struck there. The public method that I discussed about is something which is currently popular in all the pre-training web extracted data filtering and all. However, there are some insights of my own that I would like to share here. So I said the approach that I usually go with, which is something different from the most current approach, it is that I want to use the perplexity filter to identify outliers. Instead of simply running perplexity and then dropping something below 50% or so, what I do is I identify the outliers. In the outliers, the one with lowest perplexity are the ones that model may not gain much valuable information from. However, likewise, the highest perplexity items are also the ones that may contain out of domain vocabulary or information that the model fails to learn altogether. Coupling your dataset with information that the model will find really difficult to understand, or it hasn't seen that portion of data in pre-training, and rather what it is seeing is um, it is seeing that data, it is seeing that vocabulary for the first time, right? So in these scenarios, the perplexity check of dropping something below 50% would fail, and you would be inviting of bad data to your model, which will harm its performance. And removing that, identifying that and removing that is something which I recommend. So again repeating which I what I said previously, that we want use the perplexity filter ideally to identify the outliers and remove them, and not just drop something below a particular percentage. Okay. Now let's talk about the third point. The third point is curriculum learning. Curriculum learning is a training strategy in machine learning that involves training a model from easier to harder data. Again, as I mentioned previously, we have lots of methods of anthropomorphizing models, right? We treat the models as humans or toddlers, and use principles that exist in human pedagogy. So teaching a model with a data that has actually been arranged from the easiest learnable data to the highest learnable data, the easiest learnable data to the hardest learnable data, is something which anthropomorphizes them and is quite popular in existing ML training systems. It's known as a curriculum learning. And however, lots of recent research has given us some mixed reactions, or some mixed responses to curriculum learning. One of the most famous papers that uh, actually tell us that curriculum learning or something is really good can be taken as textbooks is all you need by Microsoft, where Microsoft actually created the Phi model. And in that, we saw that just trying to teach the model via generating textbooks. So first giving it some sort of text which explains the ideas and concepts, and then giving it exercises to work on, where the exercises are also arranged in such a manner that uh, the first ones are the easier ones and the later ones are the harder ones. So with these, they were able to get lots of performance, lots of really good results from a very small model. Uh, their own claim is that they get something like 7 billion parameter model performance from just a 2.7 billion parameter Phi model. And this is possible with the help of the unique approach of anthropomorphizing the model that they took. They created a synthetic dataset which completely treats the model like some sort of toddler or some sort of beginner, and teaches it first the texts and concepts, and then goes to give it progressively increasing exercises. So, when we look at these things, we understand that other approaches or other creative methods through which one might want to approach teaching these models may also have some merit. Let's jump to the next point, which is cohesivity. Cohesivity is something which you would not find discussed in almost all the popular research papers that exist, or almost all the techniques or open source repos that exist. It is something which I have uh, experimented and found on my own, and I hope to also expand upon it, and uh, um, also I hope to expand upon it, as well as share a lot of details in the next few months. But for now, I will introduce it as cohesivity. So what is cohesivity? Cohesivity is like this. Previously, we covered about diversity, we covered about perplexity, we covered about curriculum learning. In diversity, we say that we have to cover all these topics. Like topics should be diverse enough for a model to learn from. Perplexity means that the data should be appropriately chosen so that the model doesn't learn something which is like extremely basic or extremely hard. And curriculum learning is again trying to teach the model as something which is first simpler, harder. Cohesivity, however, uh, is is this particular point, that if I was to give a model 100 examples to learn something, these 100 examples could be completely disconnected each other in such a way that if a human was to go through those 100 examples, and if I was to give them a question, it requires them to use information or they use information or the concepts they have gained from these examples, combine them in in some way to get an answer. If I was to give completely 100 disconnected examples like that, would a human learn that better, or would a human learn better in the sense that these examples may have some sort of overlap and it is easier to learn them together? So this is an idea which hasn't been covered in all the popular or existing research that we have, and actually hope to both put out work as well as see more in this direction in the upcoming months. In cohesivity, we want to generate these examples synthetically in such a way or curate them in such a way where we see some sort of overlap or some sort of intermingling of concepts happening between these examples. That will tell us that if a human or a model was to go through these examples, they would actually be able to answer a question that requires them to use multiple topics and multiple ideas from different examples and arrive at the answer. This allows the model to not completely become a slave of memorization. Rather, it allows them to what should I say, actually take a truer step towards generalization. Now, the final point is something which lots of people may have heard about already. This final point is a step-by-step approach of solving something, tree of thought approach of solving something, or pause and generate. Let's cover them. Step by step is simple. You give a model a prompt, and then you ask it to tackle the problem in a step by step manner instead of asking it to just instantly arrive at the answer. When we ask it to go step by step, we've seen that all the reasoning as well as the mathematical performance of the model has actually improved. Its error rate gets reduced a lot. Observing those things, we started generating data sets that were completely focused on solving the problem step by step instead of directly providing instruction and response as the answers. So even the responses that we generate now are synthetically or with the help of humans. We want them to cover step by step approaches. Tree of thought. Tree of thought again is the idea that we want to cover something, so we want to expand on that idea in both depth as well as breadth. So we start from something as 1 plus 1 is equal to 2, and then we go a bit into depth, and then we may branch out on other areas, and likewise we may start covering it in breadth and cover some adjacent ideas as well, not just arithmetic. We may continue expanding and may touch upon other ideas as well. So tree of thought is something which allows a model to take multiple approaches, and in all of these approaches minimize the typical errors or typical mistakes it makes when it's always asked to just directly arrive at the answer. A very famous model called Cynthia uh, exists, where the entire dataset, almost 80,000 rows of dataset, is generated with the help of system instructions, forcing the model to think tree of thought. Now, the final point, pause and generate. So, pause and generate is based on this observation and later on expanded and covered in a paper, where it was observed that if we take a model and ask it to give an answer and force it like something very specific, like you have to just say true or false, or you just have to output this particular number. If you were to give it a riddle and not allow it to perform any sort of computation, calculation, or any sort of thinking, as people would like to call it, and just say the final answer. In those scenarios, we have seen that pause and generate, or asking or letting the model generate as much as it can before it arrives at the final answer, has improved the results a lot. So yeah, so essentially these are all the ideas that you would want to be present in your data set. You would want it to be diverse. You would want to use some perplexity mechanisms, and you would want to ideally arrange them in some sort of curriculum learning fashion. Cohesivity, if you can include it, it would be wonderful. And again, each and every row and response include some sort of step-by-step process or some sort of thinking or reasoning steps that the model takes to arrive at the answer before it generates the final answer. All of these things have shown that a model learns a concept very well, as well as it demonstrates the same behavior after the fine tuning. it follows the same methods of learning. It follows the same method of solving things, and that's how we get we get really really good state of the art models. You would want to study some existing data sets to identify these techniques, to identify these items yourself, whether it is something which comes to pre-training a mix of data sets, or whether it is for your let's say fine-tuning of data sets. So in both the cases, I've actually collected and shared some of the most famous best open source data sets. Like all of these are very high quality data sets, and I'll just like go through them and introduce them very quickly. The first two are your pre-training data sets. The first one is star coded data. If anyone starts building a completely dedicated code generation model in today's date, they would be relying on star coded data for sure. Then we have the stack dedupe. Dedupe stands for deduplicated. The stack is a famous data set, and the stack dedupe is a deduplicated version of the same. Then we have Hugging Face H for ultra feedback binarized. So if you have heard about the famous model called Zephyr, the Zephyr, so Hugging Faces Zephyr model, which is a Mistral 7 billion fine tune, is something which has been not just fine tuned, but also it has actually been performed RL with a technique which we call DPO, direct preference optimization. So for that, we just do not have our instruction response pairs directly. We do not have datasets simply as instruction and response or user and assistant. The format isn't simply that. Instead, the format is something with a preference. You would have instruction and response pairs and user and assistant pairs, but you would also have a rejected sample for the model to learn what is not preferred versus what is preferred. So when we look at ultra feedback binarized, it is something which is a much cleaner version of your DPO dataset, which led to one of the best Mistral 7B models that we have, which is Zephyr. Then we have Maji Coder series. Maji Coder series is currently on Human Eval Plus leaderboard, I would say, because recently Wizard Coder was also released. So Magic Coder series is the second best open source coding series that exists, and DeepSeek models were picked up, and these data sets of Magic Coder Instruct, Magic Coder OSS Instruct, uh, were used to fine tune those models, and we have the best models in open source that exist. So if anybody was to pick up any good code generation based model, or even if they were to pick up good generic based model, and they wanted to, let's say, maximize the amount of performance they can get in less than 200k instruction response rows of dataset, then I would suggest them to use Magic Coder, because Magic Coder is actually proven to lead to a state of the art result model. These are the two Magic Coder series models. Then for math performance, we have kind of magical dataset. It is so magical of a dataset that lots of people have even doubted and repeatedly claimed that it may have some sort of contamination. But the authors have run contamination checks, and their own claim is that it doesn't contain anything which can be used to cheat on the results. But with MetaMath QA dataset, it has been seen consistently that 10 points of GSM 8K performance boost always comes. So if anybody is building a generic model, they should consider MetaMath QA for sure. And if anybody is doing something which is like primarily focused on math or reasoning, then yeah, again, MetaMath QA will be a top recommendation. Then we have OpenOrca dataset. OpenOrca dataset is an attempt to uh, OpenOrca dataset was an attempt to replicate the famous Microsoft paper, which was Orca, and as a result, this particular dataset is very rich, very high quality, and if anybody wants to create their own mix of datasets, even the Open Hermes dataset which exists right or Ouroboros or Dolphin dataset, like all the best uh, generic models that exist right now have been trained on OpenOrca. So you expect to find OpenOrca everywhere. And thus, if you were to study, learn, or create your own mix of finding datasets, I would suggest to use OpenOrca for sure. So yeah, so again, the remaining ones are there. The one at the bottom is Technium's Open Hermes. This is again to differentiate it. Like this is not the Open Hermes 2.5 dataset, which is the latest model's dataset. Uh, this is from Hermes 1, the first Hermes series model, which is released by News Research team. So yeah, so all of these models are your best open source datasets that you can study as well as use if you wanted to create your own state of the art coding models or state of the art generic models. Then you would want to create some mix out of these. So yeah, now we discussed lots of technique in this talk. I didn't want to start diving deep into lots of terminologies and introduce newer vocabulary. But for people who wish to actually see the source of these claims or actually wish to understand these things more in depth, where lots and lots of experiments have been performed by academia and researchers, then these are the papers that one should use. Uh, you have the dataset best papers, the final link, which is what makes good data for alignment. This is a very recently released work as well, and in this recently released work, the repo which you see as mentioned here, the DEITA, is actually a ready-made repo which anybody can use to generate their own synthetic datasets immediately. If they want to introduce more ideas into it, expand upon it, add their own techniques, they can always pick up DEITA and then start making changes. So DDITA or data, a way to pronounce it is also there, which uh, is very good place to start if somebody wants to generate their own synthetic data sets. Now for the tools and OSS repo, which you would need to perform all the deduplication filtering stuff. The first one is Lilac. Lilac is gaining popularity. Uh, Lilac is a very useful tool. Currently, it's a bit buggy, but uh, Lilac is working closely with News Research, and News Research is giving lots of feedback to Lilac. So we actually expect to see Lilac to emerge as one of the best dataset tools in the next 1 to 2 months as well. And I would suggest that if you wanted to start trying out anything new, or you wanted to identify any personal identifiable data like emails and other stuff that you want to eliminate from your datasets, or if you wanted to perform some sort of labeling, or if you wanted to perform some other sort of clustering check on your own data to identify whether it is diverse enough or not. Like all of these things, a very good UI is also present with Lilac. So Lilac is something of a strong recommendation. Then we have Galactic. Galactic is another good open source repo which covers your deduplication and filtering techniques. And then Argila's distillable. It is something which primarily focuses on AI feedback to identify your dataset rows being good or bad. But all three of these are very good tools to use if somebody wants to just like if somebody is wondering how do I apply these techniques or where do I start if I wanted to curate my own datasets or filter my own datasets and identify chunks which are high quality, then these are the that you need to go. Yeah, so that was all from my side. Any questions on this?
Yeah, we have a couple of questions on Zoom chat. Shikhil, if you would like to unmute yourself and ask your questions, that work.
Yeah, sure. Hey, Abhishek. So my question is that how do we identify this data set is a high quality versus this data set? I mean, just by looking into the data set, how we can understand that? I know that you have explained in the first slide what is a bad data is about, but if you can take an example, that references that you were showing, you can go through that. Okay, and let's help me understand, visualize that part.
Yeah, so actually I covered both of the points, right? Good data versus bad data.
Hmm.
So bad data is something which is like obvious, as you can. If I was to just jump to that slide back, let me. Yeah. So bad data set is again things that you can programmatically identify and eliminate, like truncated items. It's easy to understand what does a truncated sentence or document look like. Again, if it is something which is hard to catch with programmatic tool, then use an LLM
Okay.
as I've given example.
Abhishek, could you
It,
please explain with an example? I am finding challenge to understand this part.
no, can you tell me what challenges
Okay, when you
for
say ki, okay,
yeah.
the truncated part, so I mean, you can highlight, okay, this is how it's look like, this is how, okay, the bad
So
data look like.
yes, if you look at this example,
Mm-hmm,
okay, let's look at this snippet here.
mm-hmm,
This is an instruction. Read the following text and determine if it ends abruptly or is incomplete.
mm-hmm.
Okay, and this is the text chunk that we're looking at. The process of photosynthesis in plants involves the conversion of light energy to chemical energy. This is crucial for the production of oxygen and the absorption of carbon dioxide. The key elements of this process include this is an abruptly ending sentence. Easy to
Okay,
understand, right?
right,
Yeah,
right, yes.
yeah. It's extremely. In fact, like I will say, it's just English, right? Terminated sentence. That's all. Terminated sentences, terminated paragraphs, things which couldn't be completed because of API call failures or because of your scraping tool failures.
Mm-hmm.
Places where these things either have been terminated abruptly, or they have been repeated again and again because the
Mm-hmm.
same response was sent multiple times. These are the examples that you would typically have for truncated items. Yeah,
So, okay, if this is the truncated data set, so what is that, solution that we should apply? Should we remove this truncated data set
we
altogether?
should remove.
So
Yeah.
you mean to
So
say
so
that
for
this entire line,
yeah
starting from the process of photosynthesis, still is the key element of this process include dash dash dash, should entirely remove.
yeah. So how do we expect to see this in your particular data set? If you're working on pre-training data, right? You're working with trillions of tokens of data,
Right,
and in trillions of tokens of data, you've identified some millions of examples that might be getting terminated like this, or it might be
right,
in billions as well. Okay,
right,
if you wish to preserve the data, like you know that this particular data something which requires representation in the final data set, then you shouldn't drop it. Then you should like try to either complete it in some manner. For
What
example,
do
by
you
running the scraper again or running the API call again, if you can.
what do you mean
But
by that? Ki this
consume,
incomplete data require a final representation, so you should not drop that. I didn't
yeah.
understand this part.
Okay. So let's go back to the point of diversity, right? And okay, so this particular topic is about photosynthesis.
Hmm.
Suppose we had trillions of documents which were essentially science textbooks or science websites that we were scraping, and there
Right,
was an entire section related to photosynthesis, right?
right,
And and my tool errored out when I was going through the photosynthesis section, and that's why it has been terminated like this.
right,
So if I just delete everything, that particular piece of information would become completely missing
right,
from the model's knowledge, right?
right,
If such a thing is happening, I want to either rerun the calls,
right.
or I want some other mechanism to fix it.
Right.
Ideally, fixing it is hard because you would be generating some artificial data, but rerunning the scrapers or rerunning your API calls is what will be assisted in those places.
Makes sense. But in such a long call, I mean, this running a web scrapper, it could be a multi-stage processes, right? How would you identify it has dropped that particular sections? So probably you'll have to set up some observability around it to determine, or I mean, how it's generally being done. Because when you are running, your scrapper is running for an n number of days, you might not know, okay, this has dropped this piece of data, or I have to rerun it altogether. How would I identify that part?
Yeah, actually, not just scraper, because almost 90% of the data that you would be picking would be existent web data already. Like anybody who is going to create their own pre-training data mix or fine-tuning data mix isn't going to create it from scratch. Like even the companies who are pushing out open source models like Mistral or Meta are also using the stack pile datasets which already exist. So
When
they
you say
don't know
stack,
exactly.
when you say stack file data, I believe this is the internet scrap data only from all the website. They may
Yes,
have a
yes,
scrap date, in a
right,
very unstructured fashion, like text out of those
right,
all of the HTMLs and
right.
put it as a
Yeah,
simple long string.
right, right. So in all those cases, they actually don't have any control or information exactly where it was
Right.
scraped from, right? So they can't actually do it. In those cases, they will have to drop it. But if the information is completely absent, then they would have to rely on alternate sources to populate information for those topics.
Just a quick question on this. How do we identify, okay, these are the set of information I have to scrap? Because that's also we
Yeah,
don't know upfront key what all
let me
information
cover.
we have to scrap, right?
Yeah, yeah. So actually, in the good data part, when I mentioned is the first idea is diversity. We want to cover enough concepts. As I mentioned, that photosynthesis might be absent if you deleted that chunk, right? Or if that chunk was never scraped in the first place, that piece of information will be absent. So diversity is something which you identify via clustering tools. If you were to so Lilac is a very good tool as well as Galactic. Both of these allow you to run k-means clustering, k-means clustering or some other clustering algorithms dataset, where they would automatically chunk your data, like group your data in different clusters, and come up with a topic for each of these clusters. So
No.
if you were to use Lilac or Galactic, then be able to work with your dataset to automatically identify some sort of representation in terms of like topics, where you're able to identify, okay, I have this many topics, each of these topics have this many examples, whereas this particular topic seems very sparse. I probably need more data for this particular topic. That sort of decision be able to make with Lilac and Galactic.
Okay. So, well, I believe this must be in the some.
Shikhar, sorry
Yeah,
to
sure.
interrupt, but we're running out of time and we've got a couple of more questions. So if you
Sure.
don't mind, you could connect with Abhishek over the WhatsApp groups or on private DMs, if
Sure.
that's
Sure. Yeah.
okay. Thank you. Nishant, would you like to ask a question?
Yeah, sure. So I wanted to, so you mentioned data cleaning with smaller LLMs.
Yeah.
So if we are running quantized versions of these LLMs like 8-bit or 4-bit or something, how much does it affect their performance in cleaning this data? What level of quantization is okay? Because obviously, it's very expensive otherwise.
Yeah, yeah. So if you were to say 8-bit quantized data, 8-bit quantized data is almost considered to be 8-bit quantized models are considered to be almost lossless. Okay. If you go on Hugging Face and pick any model quantized by the block, you would see that he always shares a table, and in that table he would exactly mention what particular what particular bit quantization has what sort of expected. Okay. uh, People have found their own balance to be best in like 5 km quantized bits, or lots of people even use q4 km ones. But if you just like wanted, okay, I can afford 8-bit quantized models and I want lossless, that is something which I'll recommend. If you're really working with really small models like 3 billion something, then I will say 8-bit is good.
Okay, thanks. Just one more
Yeah.
follow-up. I know it depends on the task, but if we are, say, fine-tuning an existing LLM to work on some downstream task, what is a good sort of ballpark data set size? And how much of a difference does, using like some PEFT techniques versus full fine-tuning make? Yeah, how much of a difference does it make?
So there have been some experiments conducted on these to identify whether PFT actually leads to worsened performance or not. I'll say there is definitely some uh, performance drop that we see with PFT, but but there are certain, for example, for SQL coder, people actually use PFT, and in their own experiment, which was published by Anyscale, there is a blog by Anyscale, where they have actually showcased that for something like SQL, we were able to get comparative performance in PFT versus non-PFT. I'll say the final thing is that you should try PFT and non-PFT and see whether it actually works for your case or not. But expect always some sort of minor drop of quality with PFT. Yeah.
Okay. Yeah. Sorry. Just one last. What is a good data set size for fine tuning? I know it depends on the task and so on, but
Yeah.
yeah.
If your task is very focused and if it is something which, let's say, can be completely represented and like and even breadth of it can be covered in 3000, 4000 examples, that is typically good enough. We had a very famous paper called Lima showcased that you can just use something like 3000 data sets, 3000 rows of data set to get uh, to fine tune a model for something. So I'll say that you don't always need very large data sets. If your task is focused enough, if it contains limited number of use cases and they can be represented well enough in some 1000, 2000, 3000 rows, start with that and increase it if it is not satisfactory. Yeah.
Got it. Thank you. Great talk.
Thank you. Chandrakant, would you like to ask your question?
Yeah. Hi, Abhishek. This is Chandrakant. So my question is like, I have few sample data, which is like in a contest question and answer, but it's very less, and I am fine tuning a llama. So I want to just generate some synthetic data, and this is based on the legal data. So what kind of tool I should use?
Start with DEITA, the one
Acha,
which
acha,
I
okay.
mentioned,
DEIT.
right? Yeah.
Okay,
So,
okay.
yes. So if you want to synthetically generate, I'll recommend checking both John Durbin's Ouroboros repo as well as DEITA. DEITA is more recent and more complete. So DEITA should be able to help you a lot.
Okay, so the other one, can you just paste it here somewhere? I just could not get it. John
Yeah,
Boros
sure.
something. Okay.
I'm just going to in chat. John Durbin's Ouroboros self-instruct repo. Okay. Put it in the chat.
Okay. Thanks.
Sure.
Cornish, would you like to ask your question? And this would be the last question due to a lack of time. But if anyone wants to get in touch with Abhishek later on, you could connect with him on the WhatsApp groups as well.
Sure, Anveshan. Thanks. Hi, Abhishek. Great talk. Just wanted to understand for what use cases should RLHF be considered and for what use cases SFT should be considered.
Okay. So suppose you've created a coding model and you do not want it to talk about anything other than coding, right?
Right.
Now you have a very specific use case where you want to punish the model for ever trying to answer anything which is not related to coding. Likewise, in all the scenarios where the behavior is something which you can like very clearly define like a rule. In those cases, go with something like RL method. Like you can use PPO or DPO. Okay.
Okay.
SFT should be where there are no clearly defined rules. You want the model to be a bit creative but still follow a pattern. Like in those cases, SFT is good. With very clearly defined rules, go with the RL methods.
Okay. Got it.
Great. Thank you, everyone. Thank you, Abhishek. It was a great talk. Nishant, to answer your question, I think we will be sharing a link to the slides. If so, I will send out an update. And also, lastly, I'd like to encourage all of you to, participate in the hackathon and submit your ideas. It would be great to see some diversity in the project. Yeah, feel free to, get in touch with any of us if you have any questions. And that's all for today. Thank you everyone for joining us. We have a couple more pre-hackathon sessions before the 3rd and 4th of February, and the details are on the project page that I shared. Thank you, and have a good night, everyone.
Thank you.